Alright, good day and welcome again to another installment of our supplementary video review series for Programming 1. So last time we talked about selection, the different forms of selection, starting with the if, followed by the if-else, and then the if-else chain, and then finally capping off with the switch statement. Okay? Alright, so just to add something, since I forgot to make it clear if it is not yet clear, okay, just for everyone's, just so that everyone is absolutely on the same page, okay. So in the switch statement, the thing being compared with the variable here, x, or being tested with x, is only whatever value that you placed here after the case. Okay, so case is a keyword. If we go back to the previous slide, see case is there indeed in bold, therefore they are keywords, but the value right next to it, however, is italicized, therefore in our convention it is to be replaced by an actual value, and that value, at least in C, can be any number or character. Alright, so those are our comparisons for now. Okay, we do not compare strings inside of switches, okay, at least not this time, not in C. Alright, so having that said, we'll now move on with our next control flow. Hopefully everyone is ready and you've caught up with caught your breath from the last time, if you are doing a marathon right now. So here we go, let's get excited. We're gonna go into repetition, another very useful and important control structure. Okay, so basically this is also what we call as looping. So what is looping? Looping is basically performing a set of instructions again and again, okay, for as long as a certain condition holds or is true. Okay, so what are the parts of a loop? In any loop, there should be at least 3 or 4 parts, depending if you include the body of the loop as a count. So anyway, the first part should be initialization, wherein we give a value for the variable that we will be, or variables that you will be using in your condition. Next is, of course, the condition itself, which is what most loops start out with, and then the body of the loop, the repeat block, and lastly the variation statement. Okay, so the variation helps us to change the value of the variable used in our condition. That way we don't end up with an infinite loop. Okay, because of course if the value of the variable in the condition is always true and never changes, then of course that will result in an infinite loop, because again, a loop will continue to execute its body for as long as the condition it is given is true. Okay, so a looping occurs when a program needs to evaluate a given condition, and if the condition holds true, keep performing a set of procedures. So basically you can think of a loop just like an if. It needs to decide, should I do this or should I not do this? And if it is true, it is probably worth doing. If the condition holds true, yes, it is probably worth doing. If it is false, it is probably not worth doing, or surely not worth doing. Okay, so here in this example, we have a code here with a sample loop. In this example, we are using one of the 3 loop structures that we'll be discussing, and that is the while loop. Okay, so the while loop acts just like an if. The only difference is that after it has tested the condition, and if it is true, then we will execute the body, and if it is not true, we will skip the body, right? Just like in our branching lesson. The only difference is the moment that we reach the ending code block, or the ending curly brace of that code block, instead of going right onto the next piece of code, we actually go back and then test once again the condition whether it is true or false, until such a time that it becomes false, and then we exit the loop for good. Okay, So in this example, we are given counter equals 1. That is our initialization. We set a initial value to our counter variable, because our counter variable is used in our condition here in the while loop, wherein the condition states that while, or for as long as, CTR is lesser than the limit being another variable whose value depends on the user input. Okay, for as long as CTR, which starts out at 0, is lesser than whatever the user inputted, okay, then we will do the following. Number 1, increment CTR, or in other words, add 1 to whatever was the previous value of CTR. In this case, that would be 0. So 0 plus 1 would now become 1, and then store it back onto CTR. And then we would print a new line and, well, a number, the value of CTR itself, therefore printing 1 on the screen. And after that is done, instead of going right away to the next statement, we will first go back and then test whether this is still true. Now, if you notice, CTR is no longer equal to 0, because on the last iteration, or the last time that we entered the loop, CTR indeed changed from 0 to 1. However, since 1 is probably still lesser than what the user inputted, probably if, let's just say, the user had inputted 3, then this would still be true. 1 is lesser than 3, just for example. Okay, this could be any number. Okay, it could be 1000, but for this example, we don't have that much time in the video, so we will assume this is 3. Okay, the user inputted 3. Maybe it's because it's the user's favorite number. Okay, all right. So 1 is lesser than 3, therefore we will execute, and CTR will get another plus 1. So CTR was previously 1, it will now become 2, and we'll print again the value of CTR, which was 2. Yep, and we will go back at it again, and currently CTR is 2, still lesser than 3. Therefore we'll go in and then we'll increment CTR 2 plus 1 is now equal to 3, and then we will now print, okay, again, because that is the code right next, and then we will go back it again. But now, since on the last iteration we changed the value of CTR from 2 to 3, 3 is now being compared as lesser than 3, which is of course no longer true. It is false. Therefore we do not go through the body of the loop. Instead we skip and we go right away to the next statement that follows. Okay, so we'll now print, well, that was fun. Okay, so if we look at the flowchart, this is it. We go for an input from the user. We then determine this condition, whether it is true or not, just like an if statement. And then if it is true, we execute the body. But the only difference is, after executing the whole body, we actually go back to the condition. Okay, and we keep doing that for as long as, okay, this is the point where the decision is to be made. And for as long as that is true, we will repeat. Okay, and finally, when it does prove false, then we exit. Alright, and that is basically what a loop does. It evaluates its condition. If it is true, do that again. But when such a time comes that it is false, it exits. Okay? Alright. Alright, I hope that's clear. And let's move on. So while loop, again, this is what we introduced in the previous piece of code. It's used to perform a set of tasks repetitively. So the condition, if the condition proves true in the while statement, or the while loop, the program will execute the line of code next to the while statement, or rather the condition, okay, also known as its body. If the condition proves false, however, the program will immediately exit the body of the while loop, not performing any of its contents. And this is useful when you have parts of your program that needs to repetitively perform an operation or a set of operations. Okay, so here we see the very simple syntax of the while. We have the keyword while followed by a set of parentheses, and in between, again, a condition, just like the if. Right, and then we have a body. So here we have the same piece of code, but this time, instead of getting the limit from the user, we assumed it as a constant, or a literal value of 5. So in this case, and in this example, we start at 1 instead of 0. So is CTR lesser than 5? Yes, that is true. Therefore we print first and then we increment. Okay, Notice there is a difference. Earlier we incremented first and then we printed. That was because we started at 0 and we wouldn't want to count starting at 0, or at least not in this example. That is why we incremented CTR first before doing the print. But in this case, since we already set it to 1, we can go right ahead and print 1 and then do the incrementation later. Okay, so note here, CTR is actually doing two things. Number one, it is satisfying the purpose of the program, which is simply to count numbers by changing in values and thus being printed on the screen every time. And also it is acting as the condition, okay, or part of the condition of the loop, such that when CTR is finally greater than or equal to 5, it will then exit the loop and proceed to the next statement. Okay, so that's initialization, that is condition. Okay, this is sorry, that is supposed to be condition. That's a typo. Okay, I'll fix that later. And okay, again, this is not initialization, that is the body. And lastly, this part should have been labeled as variation. Okay, apologize for the slides. Okay, rest assured the ones that you will get will be corrected. Okay, alright, so in fact let's do that right now. Let's pause the video. Okay, alright, so welcome back. I've applied the edits and saved it, so this is corrected now. That's better. Alright, okay, so again, yes, that is the initialization followed by the condition, the one that we test, the body of the loop, which also includes the variation to change the value so that this does not become an infinite loop. Okay, now another loop structure is what we call the for loop. Okay, so the for loop works similarly to a while loop, though the only difference is that initialization, condition, and iteration or variation statements are all gathered into a single line. Okay, so that is simply the case. It is just making things more readable, and this is very good for what we call as counter controlled loops. Okay, we'll get there in a moment. If you don't recall them, I hope you do, but anyway, so this is what the syntax for a for loop looks like, or is. It starts with the keyword for followed by a set of parentheses, and you have initialization, a mandatory semicolon, condition, another mandatory semicolon, and then the variation. Now note, initialization and variation are actually optional here, meaning you could still choose to initialize outside of the loop, just like what we did with the while, and you can also choose to do the variation inside of the body, just like what we did in the while. But then again, why use a for loop if that is what you are trying to, or going to be trying to do anyways? It just defeats the purpose. So if you're going to do that, you might as well use a while. But in this case, if you are going to use something like this, if it's just a simple counter controlled loop, you are better off with a for loop structure. So as you can see here, CTR is no longer initialized here, but inside the loop itself, and CTR is also CTR lesser than 5 is still the same condition that we used. We just recycled it to make it easier, and this is our variation. So instead of counting right after the print, we instead do the counter plus plus inside of, or right next to the condition. Now do not be fooled, this part, even though they are all in the same line, it is still only the condition part that will be re-executed, okay, after every iteration, after every full cycle. So the CTR gets 1 here will only be executed once, okay, during the start of the loop, and then we will do CTR lesser than 5. We will interpret that condition for the first time, after which, if it is true, we will perform the body, and then and only then will it actually go back here, perform the variation statement, and then do the condition, or test rather the condition once again, if it is still true, which is probably so, because at this point probably CTR is only equal to 2 because it was 1 and then we added here plus 1. Now CTR is equal to 2 and lesser than 5, which is still true. We shall then print 2, and yep, we go back here, not there, but here we increment CTR. So 2 plus 1 now becomes 3, and 3 is still lesser than 5, therefore we print again, we print 3, we go back here, it becomes 4, 4 is lesser than 5, we then print 4, we go back here, and 4 plus 1 is now 5, and CTR is, or 4 is still lesser than 5, we print 4, and now CTR is 5, and 5 is not lesser than 5 anymore, therefore we skip this, we exit the loop, and we go right here right away. Right. So yes, this program prints the current value of CTR for as long as CTR is lesser than 5. Right, lastly now for our loop structures, okay, we now have what we call as the do-while loop. So of the two structures we've discussed so far, the do-while is indeed more different, okay. It kind of acts like a while loop, okay, but there is a catch, and that catch is that the condition is checked last, or the condition is checked after, okay, only after the first iteration, meaning after going through the whole body of the loop one time. So after that, then and only then do we ask the question of the condition. So a do-while loop guarantees then that the loop body is executed at least once, since there are no questions asked, okay, during the first try through the body, okay, regardless of the truthfulness of the condition, okay. So do-while loops are recommended for what we call as sentinel controlled loops, or those with a guardian or a sentinel value, basically when we are not trying to count up or down, but simply trying to match really if the variable being tested matches or does not matches a certain value. Okay, so we'll see that in a moment. Okay, they are great to use rather when continuity of the loop depends on the user's input. Yes, that is one application of this, okay, or even if it is not dependent on the input, if the variable being used in the condition is dependent on a formula or a return of a function that is executed in the body. In that case, you will most likely need to do a do-while. Alright, those are some cases. Okay, so here we have the structure. We have an additional keyword called do. Yes, that is not the same do that we use in the pseudocode, but this is really a C keyword, do, followed by a curly brace in the body of the loop, which could include n number of statements, followed by a closing brace indicating the end of the code block or the end of the loop body, and followed by, interestingly, followed by a while keyword, a set of parentheses, and of course the condition in between. And oddly enough, this is probably the only loop, okay, that always ends with a semicolon. Yes, at this point we do include a semicolon at the end of the while. That is not true for the for loop or the while loop, but only the do while. So here we have an example. Given declared an integer input, do the following: print the number of CTR, whatever that is. Oh, CTR is actually not, oh, okay, my bad, again, this is a typo. Let me fix that for a moment. There we go, that's much better. So instead of printing an imaginary CTR, instead, no, we actually ask the user to input a number. So that number can be anything for as long as it is not equal to -1, because should it equal to -1, and why do we have quotes here? I'm really sorry, another correction. Let's just go right ahead and remove those. This is not a character, therefore, nor a string, therefore we do not need the quotes there. Okay, save that, and then let's go back in. Right, so in this case we're gonna get a number from the user, %d integer, yeah, and then as long as the input is not equal to -1, we're gonna go back and then execute the body of the loop again, and then that means we're going to ask for another number, overwrite the old value input, and then test for input if indeed again it is now -1. So if it is not, we go right back in again, and for as long as it's not, we keep doing that. But at the moment that it is, once the input is equal to -1, then this will become false, therefore we will exit, alright, the body of the loop. Okay, I hope you're able to take all of that in. Yeah, so regardless of the value of the input, garbage by default, yeah, the loop's code will be executed at least once. That's given right there. Alright, now let's talk about what we mentioned a while ago. Okay, so sentinel versus counter, no pun intended. Okay, so loops whose number of iterations are fixed or predictable, those that we can forecast ahead of time, those are what we call as counter-controlled loops. Okay, they will always execute n number of times before exiting, and that n could be predefined or preset by the user. Like for example, earlier in one of the slides, we had there. Let's just try to go back at it. We're now currently slide. I think that was slide 25. Nope, not the for loop. I go further back. Alright, there. So as you can see right here, 5 is actually locked in. It is preset no matter what. It will always compare to 5. However, that is no longer the case here when we go to slide number 29. Okay, counter control, we actually have an example. So okay, yeah, this is for counter control. Yeah. So loops whose number of iterations are fixed, predictable, and characterized by counter variable being compared against a constant in the loop condition. Right there. It's being compared with a literal constant 5 in the condition. So for as long as that is true, we will continue doing the following. I know you can read. Now, for counter-controlled loops, they are also characterized by a counter variable, gradually counting up or down using the plus, usually using the plus or the minus operators. Okay, so that simply means whatever the previous value plus 1, and this one is the opposite, whatever the previous value minus 1. So counter-controlled loops are usually used with the following relational operators: greater than, lesser than, greater than or equal to, and lesser than or equal to. Okay, for their conditions. Note, you still can actually use equality and inequality. However, it just wouldn't make that much sense because it is actually safer to also check if whether the number is still within the range. So if it is still greater than or lesser than, depending on what you're trying to do, rather than just waiting for it to become equal to something, and all the more for us to wait for it to not be equal to something. Okay, that is also not the ideal case for a counter-controlled loop because it's not counting. Alright, so here we have enter the max num to count to. Again, the user shall now decide what number he wants the program to count until. So let's just say we input again 3. So we do a scanf. 3 gets stored into max, and then we count for as long as CTR is lesser than max, which starts out at 1. We'll do the following: print, and then increment, and then determine, and then if true, print, and then increment or variate, and then simply execute, test the condition again. Alright, that's it for counter control. Let's now go to sentinel. Okay, so what is a sentinel controlled loop? A sentinel controlled loop is simply one whose iterations are unknown, opposite to the countable or predictable counter controlled loop, and this loop will execute until a certain condition is met. Alright. Okay, so or rather is no longer met. It depends on you. Okay, depends on the context. This is characterized by a variable being compared against a sentinel value in the condition. So here, for example, the sentinel value, why does that have quotes again? One moment, sorry, really. Alright, so picking up where we left off. So these are we're now comparing input versus -1. As long as the user is not does not equal to -1, the loop goes on. These are now the symbols in the flowchart that relate to the following control flows. So whether it's while, for, switch, or if. we are doing a condition. The only thing different again is which can only be used for equality. Alright, let's take a short break before we jump right into the last control flow, and that is invocation. Alright, see you in a bit.